All right, so we have covered a lot of ground during the first couple of weeks, during the first 8 lectures, and I'd like to spend week 3, parts 1 and 2, reviewing things that we've already discussed in a more compact and concise way. So, we talked about comments, starting from a pound sign or sharp sign and going to the end of the line. If you want to keep track of a value in your program, you need to create a variable to refer to that value, and you use the assignment operator, the gets operator, the single equal to sign, to cause that variable, well, it creates the variable and causes that variable to refer to that particular value. We can do arithmetic using this collection of arithmetic operators that we talked about. Exclamation, or exponentiation, not exclamation mark. Exponentiation, the double star, has the highest precedence, continuing down to binary addition and subtraction, which have the lowest precedence. You can override precedence and also associativity by using parentheses. In terms of associativity, exponentiation is the oddball here. It associates from right to left, whereas all the other binary operators associate from left to right. And recall that these precedence and associativity rules override whatever visual cues you might try to offer the interpreter by using spaces. So if I say 4 plus 2 to the power of 3 over 1, well, 2 to the power of 3 is going to take precedence here. And then that divided by 1 is going to give me, well, let's see, 2 cubed is going to be 8. Divided by 1, that's going to be 8.0, because remember, division always produces a float. And then when we add 4 to 8.0, we're going to end up with 12.0 as our result. Okay, so as I was saying, division always produces a float. Also, exponentiation with a negative exponent is equivalent to division, so that also produces a float. All the other arithmetic operators will produce ints in the case where both of the operands are ints, and will produce floats in cases where either of the two operands is a float. So if I say 4 plus 3.0, that's going to be a float 7.0. If I say 4 to the power of 4, that's going to be 16 squared is 256, and so forth. We've looked at int, float, stir, and bool low-level data types. Ints can be arbitrary precision, so computing 1000 to the 1000th power is fine. It's going to produce a number that goes zooming off the top of your screen, but it is an integer, and that is a correct computation. Come here now. Okay, my shell doesn't like such enormous numbers. There we go, there we go. A float is always stored in 64-bit double precision. Oops, too much highlighting. A float is always stored in 64-bit floating precision for efficiency's sake. And consequently, there is a limit to how large a float you can have. If I try to compute 10 to the 2000th power, I'm going to get yelled at. If I use exponentiation, I'll get yelled at. Okay, so there we have an overflow error. Stirs are in the UTF-8 Unicode character set. That includes the ASCII character set, which is what we're using here with these American English keyboards. And we can define strs using either single quotes or double quotes or triple single quotes or triple double quotes. And which we choose is partly a matter of taste and also partly a matter of what sort of complicated nested quoting we might or might not have in our string. All right, we took a look at the print function. Print takes an arbitrary number of arguments, which can be of different data types. In this case, fair is an integer, so we're passing the value of fair as the first argument to print, and print displays that as an integer value. The second argument to print is the string Fahrenheit is, and the comma here causes a space to come out between the 80 and Fahrenheit is. Then we have another comma, which causes another space to come out, and Celsius is the Celsius temperature computed by our formula, 5/9 of the quantity Fahrenheit minus 32. Now, because of the division, this whole thing is a float, and my result here is displayed as 26.666666, and we've also got this stray 8, which is garbage out at the end here. And then finally we have the string Celsius. And I happen to type Fahrenheit is in single quotes, and I've typed Celsius in double quotes. It's fine either way. It's also possible, as we discussed in a homework exercise, to use a member function. Member function is C++. Wrong language. To use the dot format method of the string to produce a neatly formatted string involving some combination of integers and floating point numbers and strings. This particular example here, all right, I'm going to say Fahrenheit is 80, and Celsius is 5/9 of the quantity Fahrenheit minus 32. If I want to neatly format my Fahrenheit temperature and my Celsius temperature, rather than getting this default display for floats, which shows as many characters as it can, including one final character's worth of garbage, I can specify a format specifier for each value that I want to display, consisting of curly braces containing a colon, and then we can specify the field width. In the case of a floating point number, in addition to the field width, we can also specify the precision, that is the number of decimal places after the number of digits after the decimal point to be displayed. And then the format letter D for decimal or base 10 integers, or F for fixed point floating point numbers. Now, fixed point means that there will be a decimal point displayed, but there will not be an exponent displayed. If I wanted an exponent displayed, I could say 8.2e to get the exponent. All right, so the output that's going to be produced here, and let me type this in. Actually, I'll make too many mistakes. So let me instead copy and paste this print statement. All right, copied it in and pasted it. All right. Okay, so what we're going to get as output to begin with is an 8-character wide field containing a decimal that is a base 10 integer. And here is that 8-character wide field. 1, 2, 3, 4, 5, 6 spaces, 8, 0. So there's our 8-character wide field. Now, these characters here, space, capital F, space, is, space, those are just ordinary text. Those are just ordinary characters, and they are simply printed as is. So space, capital F, space is displayed. Following those, we have this 8-character wide field with 2 digits after the decimal point of a fixed point number. That is a floating point number displayed with a decimal point but without an exponent. And that is the Celsius value. And it comes out as 1, 2, 3 spaces and then 26.67. So there are 5 characters in the numeric part, 26.67. And to fill out the 8-character wide field, we have 3 spaces in front. Both integer values and floating point values are right adjusted in their output fields by default. And then we just have these 2 ordinary characters, space C. So by using these format codes, that is, by writing a string containing these embedded format codes, and then using the .format method with the values that we want to have formatted as arguments, we can get very complete control over how the output that we produce is displayed to the user. Okay, so we have the low-level data types, int, float, stir, bool. A collection type that's very widely used and very important to know is the list, which is simply a sequence of values contained between a pair of square brackets. And in this example here, I have 7, -3, 5, 0 as the initial values in this list, and M is set up to refer to the list. Now, because a list is a sequence, that means that we can index within it using a single subscript. We can also obtain slices of the list by using slice notation, that is the colon notation. All right, so I can say M sub 2 to get the sub 2 item, which is 5. I can say M sub -1 to get the last item, which is 0 for this list. And I can say things like M sub 1:3 to get a slice. Now 1:3 is going to be from item sub 1 up to but not including item sub 3. So I should get the -3 and the 5 as a sublist from the list M, as a slice from the list M. Now in the particular example here, instead of using 3, I've used -1, which is another way of indexing the final element in the list. So I get the same result there. We saw that we can use the star symbol, the asterisk for repetition, and we saw that we can use the plus for concatenation. In this case, I've combined the plus with the gets operator, the assignment operator, so that does actually modify the list M. Whereas up here, M times 2 does display the M list repeated twice, but it doesn't actually modify M. By saying M plus gets for 2, I am actually modifying M, because remember that that's the same as saying, I don't want to execute it again, that's the same as if I had said M gets M plus 4, 2 as a list. A list is modifiable. So if I assign a value to a single item in the list, that works. In this case, I'm replacing the 5 that used to be the sub 2 item with a 6. And I also have named operations such as sort and append and insert that I can use to interact with and modify the contents of the list. Okay, and then this example here. Now let me catch up with these examples here. So M at this point all right, come on now. At this point, M has 6 items in it. If I now say M sub 2 gets a 6, that replaces the 5 with 6. If I say M dot sort, I get these sorted in ascending order, or technically non-descending order. If I append -5, that puts -5 at the very end. Whereas if I use insert, I specify an index as the first argument and then a value. Now remember that negative subscripts count from the back, so this is -1, -2, -3. So I'm going to insert ahead of this 6 the value 9. There we go. So now we're up to this point. And in this assignment statement, I'm doing some slicing and a couple of concatenations to change the order of the items and also stick an 8 in between. So I'm going to get the last 5 items from the list by saying M sub 3 colon. Then I'm going to append to those an 8. Notice that the 8 is contained within a list. I can't just say plain old 8 by itself. And then I'm going to have the first 3 items tacked on to the end. So M sub 3 colon is the last 5 items. M sub 3 colon, whoops, plus the list 8. A list containing 8 is those 5 items with 8 appended. And then M sub 3 colon plus the list 8 plus the list M sub up to but not including the sub 3 item gives me all of those values. And finally I want to store that into M, and rather than retyping that, I'm going to copy and paste it. Okay, so we've got accessing individual items, assigning to individual items, slicing, repeating with star, appending with plus, and then we have these named operations as well. Insert, append, sort, reverse, and so on. We took a look at for loops, which allow you to step through the values in any iterable. We introduced various different iterables. For example, a loop is an iterable, and here we're stepping through the items within this list, one value at a time. A string is also an example of an iterable. So here we're setting greeting to hello, and we're looping through each item within the string, within the stir that greeting refers to. This is going to print out individual characters on separate lines. Let me go ahead and do that one. I'm going to cheat and leave out the greeting variable for s in hello. Let me just type the value literally, print s, and we get hello on separate lines. And then a third kind of iterable we introduced was the range function. We're giving 2 arguments here, so the first argument is treated as the beginning of the sequence, and the last argument, 10 in this case, is one beyond the final item. And so here we've got 5, 6, 7, 8, 9 in this range from 5 up to but not including 10. I'm using the end keyword parameter here so that at the end of each line, instead of having the new line, which is what I get by default, I have a space, and consequently, that gets me the 5, 6, 7, 8, 9 on the same line, separated with spaces. If I had left out that end and just said print I, then the default end is new line, and so these things come out on separate lines. The while is another form of loop, but whereas the for loop requires an iterable and steps through the items in that iterable, the while loop is controlled by some general Boolean expression that yields a true or false value. If the value is true, then all of the statements within the block nested inside the while are executed. And then we come back up and reevaluate the Boolean expression so that all of the statements in that block will be executed over and over and over and over again as long as that Boolean expression is true. Hopefully we avoid an infinite loop by controlling the loop with a Boolean expression that eventually becomes false. Okay, so here we did this little example. We're going to start the variable I containing 1, and we're saying while I is less than or equal to 10, print I as well as I squared as well as I cubed. And then we'd better make sure to change I so that this loop doesn't run forever. So I'm going to add 1 to I after I have printed I squared, and I cubed. There we are. By the way, let me reset I to 1, and we'll say while I is less than or equal to 10. Let's print this a little more neatly. This table looks kind of ugly. Let's print these in 5 columns. So 5 columns containing a decimal integer, 5 columns, that is 5 spaces, 5 character positions, followed by a decimal integer, and then 5 characters followed by a decimal integer. And we're going to format in to those format codes I squared, and I cubed. All right, so this is going to make a nicer looking table. Whoop. Well, all right, so without meaning to, I have illustrated the danger of the for loop, which is that if you forget to change the value of your loop variable, sorry about that, if you forget to change the value of your loop variable, you get an infinite loop by default. So let me try that again. This time I'm going to copy and paste so I don't have to retype. Well, it's not too much typing, and I've got to retype my print anyway. So we'll start with I gets 1 while I is less than or equal to 10. Print, okay, colon 5D. Now I don't need the space here, but I'm just putting a space in so that in addition to the 5 character positions for each digit, for each number, there's also a space in between the columns. Colon 5D, colon 5D, dot format, I squared, I cubed, and this time I am not going to make that silly mistake. I'm going to increase I by 1, and there we have a nice looking table. Okay, so each column here has 5 positions in it, and then there's a space, and then there's 5 more spaces for the column, and then there's a space, and then there's 5 more, 5 more character positions for the column. Alrighty. Now, in order to control while loops and also if decisions that we'll talk about in the next section, you need to be familiar with the equality, relational, identity operators. Those all have the same precedence. Those are all on this top line here. They all have the same precedence as each other. Equality and inequality, relational, and identity, as well as these 3 logical operators, not, and or, which have descending lower precedence than the equality, inequality, relational, and identity. And as with the arithmetic operators, you can also use parentheses here for overriding the default precedence rules. All right, well, this was a not very lengthy review. I don't have a lab set up for this because you should have done various labs and a couple of homework assignments to try out these things by now. We will have a lab at the end of the next section, so let me close out this video and we'll move on to the next lecture.